Hi sixth graders, welcome to our video about Investigation 10 in math. We're on page 524. Today we're talking about compound experiments. And we've already seen these problems before because they gave us the problems but didn't tell us how to solve them. So today we actually get to find out how to solve them. So let's read together, okay? I'm on page 524. Some experiments whose outcomes are determined by chance contain more than one part. Such experiments are called compound experiments. In this investigation, we will consider compound experiments that consist of two parts performed in order. Here are three experiments. So these are three different experiments that each have two parts. Number one, a spinner with sectors A, B, and C is spun. Then a marble is drawn from a bag that contains 4 blue marbles and 2 white marbles. Another experiment might be a marble is drawn from a bag that has 4 blue marbles and 2 white marbles. And then, without the first marble being replaced, we keep that one, a second marble is drawn. A third experiment, a number cube is rolled, right, a die, and then a coin is flipped. Okay, so the second experiment, where we have 2 marbles being drawn, is the same as actually drawing 2 marbles at the same time, like we did in our experiment in Investigation 9. A tree diagram can help us visualize the sample space, right? All possible outcomes for an experiment. Here is a tree diagram for compound experiment 1. We have the spinner, so our options are A, B, or C. We have the marble that we draw. So we could draw, if we spun A, we could draw a blue marble or a white marble. If we spun and landed on B, we could draw a blue marble or a white marble. If we spun and landed on C, we could draw a blue marble or a white marble. So each branch of the tree corresponds to a possible outcome. There are 3 possible spinner outcomes, and for each spinner outcome, there's 2 possible marble outcomes, right, blue or white. To find the total number of compound outcomes, we will multiply the number of branches in the first part of the experiment by the number of branches in the second part. Okay, so we'll multiply, we have 3 spinner outcomes, 3 times 2 marble outcomes, right? It could be blue or white. So 3 times 2 is 6. So that is our compound outcome. 6 possible outcomes. Let's see. It tells us, although there are 6 different outcomes, not all the outcomes are equally likely, right? Because how big are our spinner sectors, first of all? Are they all even? And second of all, how many marbles that are blue and how many marbles are white in the bag? Are they even? If not, the outcomes are not even, right? The probability is not going to be even. So we need to determine the probability of each part of the experiment in order to find the probability for each compound outcome. So this tells us, right, we can find our compound outcomes by multiplying our options, right? Sector A, B, or C times blue or white, 2. 2 options equals 6. So there are 6 possible outcomes. Then we can determine the probability of each of those outcomes by actually looking at the probability of each of those aspects and multiplying them together. So let's see how this works. I'm on page 525 underneath the box that says the probability of a compound outcome is the product of the probabilities of each part of the outcome. So we'll use this principle to calculate the probability of the first branch of experiment 1, the spinner marble experiment, which corresponds to the compound outcome A, blue. So the first part of the outcome is that the spinner stops on sector A. The probability of this outcome is, we look at the spinner, It's 1/2, right? Since sector A occupies half of the area of the circle. The second part of the outcome is that a blue marble is drawn from the bag. Since 4 of the 6 marbles are blue, the probability of this outcome is 4/6, which simplifies to 2/3. To find the probability of the compound outcome, we multiply the probabilities of each part. So the probability of A, landing on sector A and then drawing a blue marble, is 1/2 times 2/3, which equals 1/3. So notice that although A blue is one of 6 possible outcomes, the probability of A and blue is greater than 1/6. And this is because A is the most likely of the 3 sector outcomes, and blue is the most likely of the 2 possible marble outcomes. Now they want us to figure out the probability of each possible outcome. All right, so let's do this together. I'm going to use my very old eyes. So hard to see. We'll make a chart. Oh, these chairs though. Outcome. So these are our options for the outcome. And then probability. Just gonna abbreviate that a little bit. And make our chart. Okay, so our first option is that we land on sector A and we draw blue, and we already talked about that one, right? It depends on the size of the sector, and it depends on how many blue marbles are in the bag out of the total. And we determined that was 1/2, right? We had a 1 out of 2 chance of landing on A, times blue, which we determined is 2/3, right? Because 2 out of 3 marbles in the bag, once we simplified our ratio, were blue. We multiplied these together. We came up with, you know what? We can cancel. We came up with 1/3 was our probability for landing on A and blue. Let's look at A and white. So if we had, A will be the same, right? We have a 1/2 chance of landing on A, probability, excuse me. White, well, if blue is 2/3, then white is going to be 1/3, because we know that both probabilities have to add up to 1. So 2/3 plus what equals 1? 1/3. Okay, so landing on A and white, that's a 1 in 6 chance of probability. B and blue. Okay, here we go. We have to look at our spinner. Remember, our spinner is divided into a half, which is A, a quarter is B, and a quarter is C. So we have a 1 in 4 chance of landing on sector B. Times blue, drawing a blue marble, we know is 2/3. We can multiply those. Let's reduce first. 2 can go into 2 and 4. 1 time into 2, 2 times into 4. 1 times 2 is 1. 2 times 3 is 6. So we have a 1/6 probability of landing on B and drawing a blue marble. Let's do B white. Okay, so B once again was 1/4. White is 1/3, right? We have a 1/3 chance of that. So we will multiply. 1 times 1 is 1, 4 times 3 is 12. We have a 1/12 probability of landing on B and drawing a white marble. Now for C. And we might kind of guess that these are going to be the same as B, right? Because sector C is the same size as sector B. But let's work them out anyway. Let's pretend we have no common sense, okay? C, blue. So our probability of landing on C is 1/4. Our probability of drawing a blue marble is 2/3. We can reduce. Let's reduce our fraction first to make it easier. 1 times 1 is 1. 2 times 3 is 6. Okay, now for the last one, C in white. Probability of landing on sector C, 1/4 still. Probability of drawing a white, we've determined that's 1/3. So let's multiply. 1 times 1 is 1, 4 times 3 is 12. We have a 1 in 12 probability of landing on C and then drawing a white marble. Okay, and then we can add up our sum of all of the probabilities. When we add up the sum of all of the probabilities, it should equal what? 1, right? Okay, so here we go. Let's use twelfths. So we'll convert everything to twelfths. So if we multiplied 1/3 times 4 to get twelfths, 4 over 4, we would end up with 4/12. So every 1/3 we could change into 4/12. Okay, 1/6, we'll multiply that by 2 over 2 to turn it into twelfths. 2/12. So every 1/6 we will turn into 2/12. 1/12, 2/12, 1/12. Now let's count. Do we have 12/12? I hope so. 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay! So our sum of all the probabilities, sum of all, is equal to 12/12 or 1. So we have solved our chart correctly. Awesome. Let's move on to page 526. And it tells us for problems 7 through 9, we will consider compound experiment 2. Let's go back to that on page 524. A marble is drawn from a bag with 4 blue marbles and 2 white marbles, and then without the first marble being put back, a second marble is drawn. Okay. So the first part of the experiment is that 1 marble is drawn and not replaced, and the second part is that a second marble is drawn from the marbles remaining. Okay, so it asks us, while I erase, you read the problem number 7 to yourself. I'm going to erase very thoroughly. There we go. There's some up here still. All right, that was fun. We're going to copy and complete this tree diagram that shows all possible outcomes for the compound experiment. So here's our tree diagram. We have our first draw. Once again, we have white and blue marbles. We have 1, 2, 3, 4 blue marbles, and 1, 2 white marble. And remember, we're going to draw one, not put it back, and draw another one. Okay, so first draw, we could draw a blue, or we could draw a white. Second draw, we could draw a blue, or we could draw a white, right? If we drew a white the first time, the second time, there's still a white left. We could draw a white, or we could draw a blue again, okay? So our outcome, it asks us to list the outcome, could be B, blue, blue, right? It could be blue, white. It could be white, blue. Or it could be white, white. Those are our options that we could come out with. And we see that if we multiply, let's see, if we multiplied 2, right, because we have 2 options for our first draw, times 2 options for our second draw, we would get 4. That's the number of probabilities that we have, of outcomes that we have. Okay, we could have 4 possible outcomes. Now under number 7, after we finish our chart, it says we will calculate the probability of the outcome blue, blue. On the first draw, 4 of the 6 marbles are blue. So the probability of blue is 4/6, which reduces to 2/3. If the first marble drawn is blue, then 3 blue marbles and 2 white marbles remain. Okay, so I'm gonna have to erase this. I'm sorry, you're gonna have to look in your book. So we're gonna do probability of the outcome. So our first draw of blue, we have a 2/3 chance, right? Because 4/6 of them, which reduces to 2/3, are blue. However, the second draw, how many are left that are blue? We've taken a blue already. So we have 3 blues out of 5 left. Can we reduce that? Why, yes, we can. So that gives us a 2/5 chance, or probability, Mrs. Aguilar, chance is percentage, a 2/5 probability of drawing a blue and a blue. All right, so we're gonna go through and finish our chart, but instead of drawing out the chart, I'm just going to leave our diagram here, our tree diagram. I really enjoy tree diagrams because they're more picturesque, right? I like pictures and diagrams. I'm that kind of learner. Okay, so we determined that our outcome, or our probability of drawing blue first is 2/3, and it still remains 2/3. But what about on our second draw? What is the chance of drawing a white? Well, we've taken a blue already. How many whites are left? We have 2 whites out of a total of 5 marbles. Okay, so that gives us, can we reduce anything? No. 2 times 2 is 4. 3 times 5 is 15. A 4/15 probability of drawing a blue and then a white. Okay, let's go on to white-blue. So what's our probability of drawing a white first? Well, it would be the opposite of drawing a blue, right? We could say 1 minus 2/3 is 1/3, or we could say, well, there are 2 out of 6 that are white. 2/6 reduces to 1/3. Either way, it comes up with the same answer. Times blue. So how many blues are left? Well, we're missing a white. There are 4 blues out of 5 total marbles. So we have a 4/5 probability of drawing a blue the second time. We multiply our 2 outcomes. 1 times 4 is 4. 3 times 5 is 15. So our probability of drawing a white and then drawing a blue is 4/15. White, white. Let's look at that one. We have a 1/3 probability of drawing a white first, but what about drawing a white second? Well, there's only 1 white left. So we have a 1 out of 5 chance of drawing a white the second time. So 1 times 1 is 1. 3 times 5 is 15. Okay, so drawing a white and a white, we have a 1 in 15 chance of doing that. Let's go ahead and add these together to make sure, to double check our work. Maybe I messed up somewhere because I can't see the book from here. So let's add. We need to add our fractions together to add all of our probabilities. They should equal 1, right? Should equal 1. Let's see what happens down here. Let's make them all 15ths. The only one we need to convert is 2/5. We can multiply that by 3/3 to come up with a 15th. 2 times 3 is 6. 5 times 3 is 15. Okay. 6 plus 4 is 10. Plus 4 is 14. Plus 1 is 15. Yay! Our total outcomes equal 15 out of 15 or 1. We have done the chart correctly. All right, let's look at number 9. Suppose we draw 3 marbles from the bag, one at a time and without replacement. what is the probability of drawing 3 white marbles? What is the probability of drawing 3 blue marbles? Okay, so from the bag, we are going to draw one at a time and without replacing them. First 3 white marbles and then 3 blue marbles. So we're going to have 3 draws, okay? Here we go. Third draw, let's see. We want to draw 3 blues and 3 whites. So we're just going to fill those parts of the chart in. Third, blue, blue, and then we want to have another blue and another possibly white, right? But we're not going to look at that part. Down here we would have white, white, and then drawing another white. You should already be figuring out, whoops, Mrs. Aguilar, you should already be figuring out that something here is not possible, right? But let's work out the math, okay? We're doing 3 draws. We want to look at this one right here, and then we want to look at this one right here. So we're going to draw first 3 whites. Okay, so we're drawing 1 white from the bag. We have a 1/3 chance of drawing a white the first time, right? 1/3 times, second time, what's our chance of drawing a white? 1 out of 5. There are 5 marbles left, 1 is white. The third time, what is our chance of drawing white? It's 0. Right? There are no whites left to draw. So what does that give us? When we multiply 0 times anything, it equals 0. We can come up with a denominator, right? But do we need to do that? We already know our answer is 0. It's nothing. We have a 0 probability of drawing a white 3 times in a row, because do we even have 3 white marbles? If we're taking 1 white and then taking another white, there are none left to draw the 3rd time. Come on, Saxon math, right? We could have used our common sense to answer that. What about drawing 3 blues? So our first draw of a blue, we have a 2/3 probability of drawing a blue. I feel like I need to write this a little bigger. Our second draw, we have 5 marbles left and 3 are blue. So we have a 3/5 probability of drawing a blue. Our third draw, we have 2 blue marbles left out of 4, which is 1/2. So the probability of drawing 3 blue marbles will be multiplying all these together. Can we reduce first? Yes, we can. I see a 2 and a 2, those reduce to 1. I see a 3 and a 3 that we're multiplying, those reduce to 1. So 1 times 1 times 1 is 1. 1 times 5 times 1 is 5. We have a 1/5 probability of drawing 3 blue marbles when we're drawing a marble and not replacing it, right? Now, if you're replacing the marble in the bag, that's a different story, right? This time we're drawing and not replacing. Okay, so let's look at this. We're going to go through problems 10 through 14. We are considering the experiment in which a nickel is flipped and then a quarter is flipped. Okay? So they want us to first create a tree diagram that shows all of the possible outcomes of the compound experiment. I'm going to erase very thoroughly. I want you to get out a piece of paper and work on this with me, okay? If you haven't already been working on them with me. Start on number 10. Draw that tree diagram. See how you do. Pause me if you need to, okay? Then unpause me when you're ready to check your work. Let's see how you did. So we're going to create a tree diagram, okay? Here's our nickel flip. That's our first one. We could land on heads. We could land on tails. Okay? Now we then flip a quarter. Stay right there, book. We could flip a heads, or we could flip a tails. Once again, we could flip a heads, or we could flip a tails. So our outcomes could be heads, 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 tails, tails, heads, or tails, tails. So if we take our two options for what we could possibly do with a nickel, heads or tails, and we multiply it by our two options that could happen with a quarter, we come up with our number of possible outcomes, right, which is 4. Then they want us to make a table that shows the probability of each of the possible outcomes. I am just going to keep working, okay? I want you to make your own table, and you can just keep working on your piece of paper if you'd like to. If I get ahead of you, pause me. Unpause me when you're ready. Okay, let's go erase this. Here's all of our possible outcomes over here. Okay, here's our probability. We'll just add on to our information and make a chart like that. And I'm kind of praying that you can see this, guys, okay? I might move this up so I can write bigger. All right. So let's see. With our nickel, we have a 1 out of 1/2 probability of flipping a heads, right? So we have a 1/2 probability of flipping a heads. With our quarter, how many options do we have? Once again, 2. We have a 1/2 probability of flipping a heads. So 1/2 times 1/2 is 1/4. Here we go. See where we're going with this? With our nickel, we have a 1/2 probability of flipping a heads. With our quarter, we have a 1/2 probability of flipping tails. And that gives us a 4th. I'm gonna need to extend my lines. What about tails? We have a 1 in 2 probability of flipping a tails. Heads, we already know, 1/2, right? 1 out of 2 chance. That gives us a 4th. Tails, we have a 1/2 probability. Tails, for the quarter, 1/2, right? There are 2 sides to the quarter. One of them is tails, 1/2. So we can see that there's an equal chance of any of these outcomes, equal probability of any of these outcomes. I said it correctly that time. Our total probability, 1/4 plus 1/4 plus 1/4 plus 1/4 is equal to 1. So we did our chart correctly. Okay, so let's look at number 12. I want you to try to answer this before you listen to me, okay? So if you need to pause me, go for it. What is the probability that one of the coins shows heads and the other coin shows tails? Okay. So what is the probability that one of the coins shows heads and the other shows tails? So we just need to look for all of our HTs, right? Doesn't matter what order they're in. They didn't say that part, right? They just said, what's the chance of one of them being a heads and one being a tails? Well, how we solve that is we add together our probabilities of heads, tails that we've come up with on our chart. And we see that 1/4, here they are, right? Heads, tails, or tails, heads, doesn't matter which is first. 1/4 plus 1/4 is equal to 2/4, which is 1/2, right? Very good. Now number 13, try to work this one on your own too. What is the probability that at least one of the coins shows heads? We're going to solve this in the same way. So we want to have at least one coin show heads. So we look at our outcomes, and each one that has at least one heads, one, this one does, this one does, this one does, this one doesn't, we will add these three probabilities together. So if we have 1/4 plus 1/4 plus 1/4, it equals 3/4. So there's a 3/4 probability that at least one of the coins will show heads. Number 14, once again, pause me if you need to. I want you to try to work this out. What is the probability that the nickel shows heads and the quarter shows tails? This one is very specific, right? Our nickel, which is our first, has to show heads, okay? And the other one, the quarter, which is our second, has to show tails. So we have to find a very specific H and then T. Well, there's only one option for that, right? And that's this outcome right here. So our probability of HT is 1/4, okay? If you would like to practice some more, that's fine, that's great, because probability is gonna keep popping up, especially next year. You may work through those extensions if you'd like to, or just look at them and consider how you would solve them, okay? I'm happy to answer questions on the extensions if you wanna go further and try some more math, okay? Otherwise, if you have any questions, please let me know, okay? I'm here to help you, and I want you to understand this compound probability, compound experiments, when we have more than one thing happening in our experiment at a time, and how we determine the probability of that, what our outcomes would be. All right, good luck.